Hi, this is Deepthi, a PhD student at Jawaharlal Nehru University, New Delhi, India. In this video, I'm going to present our research on a triple band circularly polarized antenna for leadless cardiac transcatheter pacing system. This research was published in IEEE Transactions on Antenna and Propagation in June 2022. Currently, implantable medical devices are enabled by wireless data transfer, power transfer, and control signaling. So, in order to fulfill these requirements, we need multiband antennas, although some researchers proposed multiband antennas for leadless pacing systems, but the antennas proposed were little larger to fit inside the pacemaker's housing. Moreover, in case of misalignment with the antenna in the external monitoring system, if the antenna is having CP radiation properties, will be advantageous because it will mitigate the multipath interferences as compared to linear polarization. So we targeted to design an ultra-compact circularly polarized multiband implantable antenna which can work well and fit easily into commercial leadless pacemakers housing. In figure 1, schematic of leadless cardiac transcatheter pacing system and representation of its location inside the heart of human body is presented, and the antenna is designed inside the leadless pacemaker's housing. In the simulation environment, the proposed antenna is designed inside the biocompatible housing of pacemaker along with required electronics, and the pacemaker is deeply implanted inside the multi-layer canonical model of human heart. Figure 3a shows top layer of antenna which is inspired from the second stage of Hilbert curve, and figure 3b shows slotted ground plane. Here, evolution of the antenna designing is presented. In the first step of the antenna is the open loop of width 0.1 mm, which is inspired from the second stage of Hilbert curve. At this time, antenna is resonating in 2.45 and 5.8 GHz band and is also showing CP behavior. The next step, current path was increased to get the lower resonances. For this purpose, a ground slot was created and shorting pin was connected from top to bottom to increase the current path. In the third step, we extended the loop at the end and followed the same pattern to increase the current part, and this change splits both the resonances and creates 4 as we can see in figure 5. Further, in fourth step, top loop and bottom both were extended along with the shift of the shorting pin. Till now we got 915 MHz, 2.45 and 5.8 GHz along with some undesired resonances. In the final step, the ground slot was modified to get only desired resonances along with the CP behavior. The detailed analysis is given in the paper. In the proposed Hilbert curve open loop antenna, current minima align itself at both the time phases in such a manner that the current factor rotates in a clockwise direction. Therefore, with a reference to an observer facing the aperture, the proposed antenna radiates with left-hand circular polarization. The simulated gain patterns of the proposed antenna in the desired 3 bands are shown in figure 6. The maximum input power requirement for the proposed antenna are 3.65 and 24.18 milliwatt only for 1 gram and 10 grams SAR. Hence, the proposed antenna is safe for long-term operation in the human body.